Well, hello, I'm Greg Eva, and today we're going to be doing a deeper dive into some of the ThingWorx performance metrics enhancements that have come over the past couple of years, as well as diving into the ThingWorx Foundation dashboard for Grafana and looking at how I have implemented those in such and how you can think about leveraging them. So first of all, I should bring to your attention a document that I've recently written and published through our internal hubs and COEs. If you're a partner, this is available on Velocity. If not, you can contact us and we can share this with you. You can see here it's essentially an overview guide on understanding some of the aspects about open source availability. You know, what is Grafana and Prometheus? Why Grafana and Prometheus? Some of the different components that you might need in order to get into some of these things, monitoring architecture, the different parts of overall solution architecture, what's in there, how you monitor it, why you need to monitor it, and a little bit of architecture, as well as getting into some of the specifics, you know, how you might want to set your system up, some things you might want to think about, where you can get the dashboard, and all finishing up with some concrete examples as far as the types of things that you might see and how you should be thinking about interpreting those. So I suggest for those who are into performance monitoring or operations of running ThingWorx in production, you should definitely check this out. And let's come back over to the Grafana website here. So here I'm just on the Grafana website where I've done a search for the dashboard called ThingWorx. And here we're going to crack this guy open. We've got a little bit of an overview description of the dashboard here with some screenshots. We've got the Prometheus YAML configuration, just as an example to get started here. We've got some additional label examples here that you might want to use to label your environments differently from one another based on the scrape configurations. Some other things we won't get into here that are covered in the document. But let's jump right into the dashboard and trying to look at some metrics and trying to understand some different patterns and how, you know, I think about using this and how I have built this. So first of all, I'm going to collapse all these rows on the side here. You can note that there's a lot of rows. This is somewhat a fortunate and unfortunate aspect of the fact that there's a lot of stuff in a ThingWorx platform to monitor. There's a lot of things that are going on, and depending on what your build solution is doing, aspects of the platform that it's using, you're going to be required to look at different parts of this. Today, we're really going to focus primarily on the key parts, and this is some of the ones I have at the top here. Platform. Everyone needs to understand some of the things about platform, and here we can see in the top part, as a Java application, you know, understanding memory patterns is super important. So we have the heap memory listed over here, and we can kind of quickly get into understanding heap usage patterns. So this is a little bit hard to see considering the fact this is a cluster with a lot of nodes. So there's a lot of lines on there. And so I'm going to just choose one of them for illustrative purposes to give us an idea of how the heap memory is behaving. This is a little bit better. I can see the allocated memory here, this yellow line at the top, that's flat. And I can see the green line, which is memory in use. So this is telling us how the heap memory usage compared to allocation is behaving. And that is extremely important as we're watching Java applications in production. I'm going to put all of the nodes back on here. Some of the other things that come up across here, one of them is the singleton column here, which I have painstakingly improved. And the goal here is really so that we can use it and look over a particular period of time, let's say over 7 days, and we can look to see if there have been any singleton changes. Singleton changes will occur if the singleton is restarted, of course, but there's other situations which could trigger that. So here we can see over 7 days, the line stays the same. P0 is the singleton, and so there have not been any singleton changes. So that's an important one to be watching as you're troubleshooting and monitoring your platform. If you see regular changes in singleton, that is not a good behavior. Over here, the event queue. This is the event processor event queue that's also surfaced on the platform subsystem. Basically, these are queued events, subscriptions that are waiting to be executed. You don't want to have queued events because this essentially means that you have work to be done that you're expecting to be executed that's been coming in that is not. Here we can see there was one event that's not really a big deal. There's one event waiting for 30 seconds or so to be executed. Typically, this should be a flat line. If you see the event queue growing or being quite high over a period of time, even a number of minutes, certainly if this is a regular pattern, this is something that needs to be resolved. This line down here, I have added in here really because these metrics, I want to say they don't really fit anywhere else. They're general metrics about things like properties, things like info tables. They're not really specific to any of the other subsystems, and hence why I have put them here. These two are actually also not necessarily reliable. They are meant to be more indicative, to get an idea of when you're having property rights versus remote property rights. Remote property rights coming from a Kepler environment, coming from a remote connected ThingWorx edge. This can kind of give you an idea, so you can compare and contrast the left and the right. Here we have these property rights versus the remote things property rights, and here we can see the remote things property rights are clocking in at around 500 property rights per second from the remote side, and here this is closer to maybe a half property per second. So let's keep going down here and just opening them up as we go. I will typically organize this depending on the type of analysis that I'm doing. If we are looking at a Kepler or connected products situation, and we probably want to have the platform row open as well as the WebSocket execution processing section open, as well as the event processor. If you don't really have data that's coming in on the WS execution processor, you can kind of collapse this one and focus in more on the event processor and other ones like this here, the model persistence provider. That's going to be an important one. If you're doing any model changes, if you're doing persisted properties, whatever is using the model of the ThingWorx persistence provider, this is the database connection pool that is going to be leveraged. So you definitely want to keep eyes on this. And here we can see that there's 100 active connections from each of the nodes, and periodically we have spikes of busyness going up to about 20 connections per node, which comparatively to the size, that doesn't seem to be too much, but part of the reason is that these connections are pre-established, and so we're not spending time ramping up and ramping down connections all the time. And this is also one of the reasons some of these modifications to the dashboards I've tried to do is to try to bring some higher coherence, where here we can see the configuration over a max pool size, where you can see the max pool size can push up to 500. At the same time, we're seeing the fidelity of some of the movements in some of these busy threads, which if they were plotted against a maximum of 500, we wouldn't really see that. Show you what I mean here. If I add this one in, actually no, I've disabled this one overall, so we can't even add it in. What else? Database helper thread pool. This one is quite important. We're likely only going to get this one through the JMX exporter instrumentation that is documented on the Grafana page. This is telling us how busy our database connection thread pool is to establish and close connections. And let's keep going down the list. Actually, for some of these, I'm going to skip over some of these and maybe look over at another environment over here for some specifics from a very different type of application than what we were previously looking at. And that is because we have some, right here, we have, what is this called? This is called a SQL string that is using a persistence provider as its backing persistence provider. So here we're using many SQL things in the ThingWorx application. Specifically, this is DPM. And those different SQL things are all sharing the same database connection pool that is a generic JDBC persistence provider. You can see it called out in the name here. And once again, this is super important if we're using a database application, that we keep eyes on how many threads are going to be provisioned, what are the maximums, what are active, and how many are busy. Here you can see this looks pretty good. We have 300 essentially active connections that are provisioned with a maximum of 500, and only few that are ever busy, which is excellent. However, if we look at another one of these environments, and just this is not a very active environment, but we should be able to see the difference between having done that such tuning. Yeah, see, this one does have the tuning done. It's P05. Okay. Doesn't seem to be loading the data that I was expecting. That's fine. We'll skip that and move back down to the environment we were just looking at here. Yeah, it looks like there's a query problem here from Prometheus. There we go. Okay, so here's another new set of metrics that didn't previously exist. These ones are disabled by default, and you can see I've put some notes or comments in the info parts of the charts here, but these are all about shared value collection caches, and this, you'll find this in ThingWorx. To enable it, it's going to put some warn messages into the logs if there are certain thresholds for these shared value collection caches that are surpassed. But at the same time, it's going to emit a metric, and that's what we're seeing here. Is we're seeing the visualization of those metrics over time. There is a field up here somewhere, I believe, collection cache all. So here you can see there's 2 collection caches that have been detected in the metrics that have those metrics being reported. I could do a deeper dive and just kind of zoom in on only one of them if I wanted to, but just by looking at this, I can see that this ThingWorx Session Manager session IDs per user is the principal one, and these charts here, these time series charts, are showing us the values, min, mean, max, value counts. So these are quantiles, 75th quantile, 98, 95, 99, 99, 9. And then the coefficient of variance is really about how the population within a given period of time are changing. Similar to standard deviation, the difference between standard deviation is this is normalized. So this is percentage based, intended to be sort of 0 to 100. Where it will definitely go over 100. There isn't a ceiling to it, but it is intended to give us a little bit of a more of a relative indication of how things are changing. Okay, let's keep going. Where were we? Here, distributed compute platform. So distributed compute platform, also known as the actor model for distributed transactions, something that we don't actually really talk about too much in ThingWorx, but what we do talk about this as is underlying infrastructure for some of the features that have been added in ThingWorx, specifically for data ordering. And what else? I believe there's something else in there. Oh yes, multi-event subscriptions. So multi-event subscriptions, ordered subscriptions, and data reordering. All of these are using this actor model for distributed compute platform. And these are the metrics that we're looking at. So we can see how many nodes the actor model architecture is running on, the memory allocation, memory limits, fragmentation, the number of actors that are currently spun up, messages that are being dispatched, and importantly, event latency. Similar to any form of event router, event processor, this is going to have an impact on how quickly things are getting done. Here we can see across the different nodes the overall event latency, which is quite handy. We have the min-max average over here, and then we have the quantiles. So these are the old style metrics from the, what's it called? drop wizard library. So this is why we get min, mean, max, and quantiles. And some of the other new ones that we're going to see later are using the OpenTelemetry library, using more histogram style metrics. Similarly here, I've put a coefficient of variance type graph. There are a number of these. You'll see the same pattern repeated because there's similar types of metrics, and I'm trying to give same ways of analyzing different patterns of performance and execution. Okay, so here we come to some of the sections that have existed for quite some time, but the expression of them is becoming more refined. So over the past couple of years, I've done some work on these sections to get rid of some of the things over here that haven't really been so useful, as well as to combine them together, things like these threshold. The intention here is to have the configuration values for these sections surface to the top, so that as someone who's doing an analysis, you can quickly look at this and see what the settings and configurations are. At the same time, you don't need to see those per node. Here, this is a 5-node cluster. I don't need to see the same number 5 times. And so what I've tried to do is sum them all together or group them all together so that we can have those over here. You'll also see this is the normal task section where we've got submitted tasks coming in here. We have essentially queue and active in the middle threads, and we have completed over here on the right. Down below, we have errors. So these are writes not queued, meaning that the queue was full and they hence were not able to be queued. We have configured thread count. So for the persistent property processor, there are 20 threads by default. We can see this over time. This can be handy more on some of the other subsystems that you actually might change those values. You wouldn't typically change this particular one, but you can track them over time as you're doing performance testing, preparation for go live, stress testing, and you might be making some changes. You can look at those configuration changes over time here. This one is a little bit intended to be related to the one on the right here, whereas this one is the number of batches written. Obviously, the batching mechanism used by the persistence engines and ThingWorx is putting multiple updates into a single batch. And what this one here is telling us is we tried to write them and they did not write. So you can see here the batch writes failed. There are some new retry mechanisms also in there, so I'm not sure if we'd see it in here, but we should see essentially a couple of lines. Yes, here we go. So in the bottom we have the total batch failed total, and then we have this writes succeeded on retry. So you'll see both of those, and let's keep going down. One thing I guess I should mention about this particular section that we're looking at right here, I have templatized this into a variable. So at the top, we have stream processors. We have the 4 stream processors that are now listed essentially as static variables up here. I can choose one of them to look at or multiple of them. If I'm not using persistent properties, for example, you can take that out of there, similar to data tables. They're all shown, but they're all the same pattern here repeated. So this means when I do any updates or enhancements, that process is a lot simpler as I don't have to redo them 4 times in order to combine the different sections. That does kind of lead to some, I would say, frustration sometimes when you're just trying to get this and this section laid out. It can be a little bit more challenging. Let's look at the next section. One of those things that I have done with that is that you'll see now there's another section down here, persistent property processor, operational performance metrics. So here it's repeating essentially all of those 4 sections, 1, 2, 3, 4, and coming into the value streams, we see the same kinds of things, right? 5 threads, 2.5 essentially batches per second. And this is then repeated for the streams, log properties, and data tables. The next section here I wanted to mention, similarly, these are performance metrics. So these are more about not what the subsystem is doing, but how it's managing to do that. So these performance metrics in the drop wizard fashion are telling us some things along the lines of number of entries per batch write. So not just how many batches were being written, but how many entries are in each of those batches. And then we get some figures like min, max, and average. So we can see, this is batch write time actually. And here we have the quantiles, right? So if we wanted to look in specifically to the 99.9 quantile, 99 quantile, we can do that over here. And here, for example, we see that there is significant latency right at this particular moment. It doesn't really seem to impact the performance of the writes that are going on, but we do see a little bit of a hiccup in write performance. So that can be quite valuable, especially if we compare some of these things. You can see here, maybe you'd expect that there's a latency hit to the database on the updates for persisted properties. We should probably see something similar in these other ones. Well, the reason we don't here is because the logged properties are being logged to InfluxDB. So this can be quite handy as we're doing different types of troubleshooting or analysis where we can look across the different persistence providers. And here we can see, for example, in the streams and in the value streams, there over here where we have submitted as well as executed tasks, we can see that the data source, the persistence provider, is called out here. I guess I'll mention also, typically when we're looking at a lot of these things, looking at throughput or rates over time is the most useful. However, in this section, we're actually interested sometimes in how many times there were retries, how many times there were errors. So progressively throughout the dashboards, I've tried to start to add some of these numerical representations, just giving us a total count for the given period that we're looking at. So for the 3-hour period here, you can see 4.7 million persisted property updates. All right, cache things. I don't have a running system with cache things up here. This was covered in the NPI training for ThingWorx 10. It's also covered in the document, but this is a section for essentially developers and infrastructure and application operators to assess the performance of the ThingWorx in-memory caches. File transfer performance. This is the classic view of essentially tasks being processed by the file transfer subsystem. There have been some issues with this in past, is that a task doesn't necessarily mean something like an upload. An upload is a task, but also canceling a file transfer is also a task. It's a cancel task. So sometimes it can be quite challenging using the following metrics to do deeper analysis. And for this reason, we've added a whole slew of additional file transfer metrics, which are focused on things like what type of file transfer is it? Is it an upload? Is it a download? Is it a repository to repository copy? As well as aspects of, is it a cancel? Was it a successfully completed? Is it being started? Has it failed? What else do we have in there? Then we have the OpenTelemetry histogram metrics, which I mentioned briefly in the overview. I'm not going to do a deep dive into histogram metrics here, but basically here in these kind of section, the bottom half here, what I've done is I'm leveraging those histogram metrics, which can be used for post-processing statistical calculations to try and give us some understanding of the overall representation of the population of those file transfers. So if we wanted to, we could do some other things like here, we have broken this down by node. Up here, we've broken this down by node. I actually just changed this temporarily the other day, so this is not the one that's in the official dashboard. The official dashboard is a little bit simpler like this, where we essentially have a view that is going to show the repository, so the type of event as well as the repository. And we can see here that there's two repositories in question. We can understand how the files are being uploaded to those repositories because we can leverage some of the labels like I just did on an accidental demonstration there. We can have a better understanding of some things like what the downloads are doing. And here we can see the downloads are actually coming from software content management downloads. So by looking at the different aspects of the files over here, the upload transfer duration, the upload transfer size, a download transfer duration. Download transfer size is we can kind of get an idea of the overall representation of the fleet. If you're interested in digging deeper into these, there's a good help article on these in ThingWorx 9.7 on these metrics. And there's 6 buckets that are listed here. If you want to increase the cardinality on this, you can add more buckets to get kind of a higher granularity. You can also set the size of these buckets. So these are default settings for the size or the width of the buckets that can be configured. I guess I should also mention while we're skipping over that section, the old 9.6 file transfer metrics are essentially deprecated with this because these are far more powerful and essentially replace them. So there's also a new feature that allows you to disable certain metrics. So you might see that in the platform settings or the platform settings configuration where you can say these metrics I would like you to never report. And so the 9.6 metrics for file transfer in 9.7 are included in that list so that they're not reported in a duplicate manner, but you can also leverage that for your own needs if there's metrics that you would specifically like to remove from reporting. I guess we're getting down to the bottom of the list here. There's a lot less to be said about this particular message store task submission. One of the things this is used for is egress messages. So if you've got egress messages where the device is offline, they're going to come through this system here. And so you would see any buildup of messages waiting for the edge device to come back online before they were sent. I have basically tried to go through all of the subsystems, all of the metrics, and put them on here. This unfortunately makes it that this is an extremely complex maybe dashboard for someone who's not used to looking through these sorts of things. But the intention is that at least here you know they are there. And when you're digging through, when you're looking for answers, you're looking for some form of understanding, then at least it's a question of you can just go through and open these sections up. You can also make copies of this dashboard and delete some of the sections that you really don't need, as well as making specific copy and paste. I should mention copy and paste. Let's just say of the event processor, here we've got the tasks being submitted. Here we've got the event queue, the thread pool status with some of the configurations. This one is super, super important. So, you could just say copy, create a new dashboard. And then once you've got your new dashboard up, you can go paste panel. So you can essentially do some of your, ad hoc pick and choose some of these key panels that I've prepared and that are distributed and updated on this dashboard, and you can make your own dashboard. All right, let's come back down to the bottom here. User manager and WebSocket communication, they're actually both quite important as well. Maybe a little bit uglier. They have gotten less focus over the years, but still quite relevant. Here we have user count and user sessions and active users over time. So here, one of the things is we can see that there is a discrepancy here between P4 and the other nodes. Can't really explain what's going on here. Same with user sessions, but this is exactly the kind of thing that you should be looking for when you're trying to figure various things out on your system. Is these numbers should be in relative coordination with one another. You obviously know how many users that you've got provisioned on your system. Those sort of things should align here. And similarly to how things change over time. If I zoom in on active users and we look at a period of time, say like 7 days, 30 days, you should see usage patterns that are emerging out of this. This type of user usage pattern is going to be incredibly important as you think about performance, scale, availability of your application, to know here that there's 325-ish active users, and this is obviously weekend, and here are the weekdays. Okay, so WebSocket communication. So this subsystem is related to all things around ThingWorx always on WebSocket communication. So similarly to the above, discrepancies between some of these are what you should be looking for here. We've got 240 essentially on most of the platform nodes. 240 maximum, right? This is because I've surfaced the maximum just to essentially get rid of some of the shift, to see if there's really a high maximum on one that's different than on the other ones. And there is. P4, 453, this is what we're seeing in the line down here and how this is evolving over time. This is due to remote access and how remote access temporary WebSockets from the remote access client are handled. So this is expected, strange but expected behavior. And the reason that all these other ones are flat is that they are pre-established connections from connection servers. Otherwise, if you're running in standalone mode without a connection server, you would see these lines here for the number of active WebSockets. They would be fluctuating in line with the number of bound connected things. Whereas here, the bound connected things are kind of going up and down, disconnected from the number of WebSockets. So this is very valuable for just understanding how many remote things do you have bound. Do you have drops? Is it stable? What does that look like? Similar pattern of those drop wizard metrics that we saw before for a number of things about authentication time. So this is about when a WebSocket connection is established and there's an authentication that is occurring through the platform. How long does that typically take? And here you can see the quantiles over here, min, max, average in here, as well as the frequency. So this can kind of give you an understanding of how many of those WebSocket connections are occurring. And this is a little bit more advanced. These other ones, more intended for debugging of egress messages. But if you've got a fleet of connected always on devices, then the WebSocket communication section is going to be quite important for you. What else? Alert processing audit. I guess audit is worth mentioning. This is also a section that hasn't received a whole lot of tender love and care, but it's also quite usable. If you're looking at using, or if you're using auditing subsystem or audit log, then this particular section is going to break down a number of the different sections for you and give you an idea of how many different events in the different categories are coming in. And you can look for a correlation between them. You can see here some spikes are coming together: file transfers, authentication, and total audits. One of the things I quite like to use this for is this archive free disk space and archive disk space used. This is going to tell us how much remaining space we have on our storage volume. So for audit, that's actually not so important, but it is a lot more important for our file repositories and for our logs. So if you are storing logs and file repositories in the same storage location as your audits, well, then you can use this particular thing to see how much space you have left. And if you come in here and just hit E to edit this, no, that's not the right section. You mouse over this here and edit it, and then change it from a stat to a time series. Then we can kind of zoom out a little bit more over a longer period of time, and we can look at how this is changing over time. And you can see over a 7-day period it is coming down ever so slightly. This is likely because of log usage. All right, I guess the last thing here before we call it a day, this is something that I've started considering. This is, I don't know if it's a year's worth of changes and enhancements that have gone into this dashboard since I last published a public version, which was around version 2. I've started a change log. So on the various days when I version up the dashboard, I am putting some specifics in here, and this is intended to support the users of the dashboard to understand, hey, here, I've got this particular version. I mean, what's different about this? Maybe one thing to mention is there are a number of places in here where I have kind of struggled, but I have made it backwards compatible. So this version of the dashboard should be, it's actually 3.0.1, and this is backwards compatible with pretty much any version of ThingWorx that you're using. So you can feel free to just go to the Grafana Labs site and grab the dashboard at 19533. And actually, if you've not done that before, you can also just dashboards and discard import over here, 19533. I'm pretty sure that's what I said it was. Yes, and you can see here it's loading that. It's giving us the opportunity to import it. Okay, that's about it. I will put a link in the description of the video to this particular document here. I hope you find this useful. Please don't hesitate to ask if you have questions or reach out if you need to. All right, take care.